So we have discussed Joule's heating, okay, practical application of heating effect of power. Now electric power. What is electric power? We have the definition of power, which is rate of work done, right? We have studied. We have studied in earlier classes, or we can say earlier lectures, that the rate of doing work is power, right? So this is also the rate of consumption of energy. Okay, so
Yes, sir.
P is equal to VI. We have already discussed and derived this equation. Okay,
Yes, sir.
and also it was P is equal to I square RT, and this equation tells us the rate at which electric energy is dissipated, or we can say consumed in an electric circuit. Okay, rate at which electrical energy is dissipated or consumed in the circuit. So this is also termed as electric power, right?
Yes, sir.
We can use this statement as our official statement for electric power, right?
Yes, sir.
And sorry, there was no T, okay? It is just simply I square R. Heat, or we can say work done, is given as I square RT, okay? If you take this T into the denominator, this becomes the power, okay? Which is our this equation. P is equal to I square R, right? So power,
Yes.
we can write it as P is equal to VI, or we can write it as I square R. And if you substitute the voltage here, okay, we need this expression V square upon R. How we will get it? How to get this expression instead of? So we need to insert the value of current, and which is nothing but the Ohm's law. I is V upon R. So if you plug in this value, so P is equal to I square R. Instead of I, we write V by R whole square into R, which is nothing but V square by R. Right? So
Yes, sir.
till now we have three formulas for power. P is equal to VI, P is equal to I square R, and P is equal to V square by R. You need to remember all these formulas. This will be very helpful in your upcoming exam, right?
Yeah.
Okay? So write this all down and we'll move forward for electric power.
Yes, sir. Now.
Okay. So how to measure the power? How to measure power? Or simply, what is its SI unit? So SI unit of power is watt. Okay, W A double T T double. Okay, so this is the SI unit of power. So what is 1 watt? Let's say 1 watt of power. What do you mean by 1 watt? It is simply we know that P is equal to VI. So if potential difference or we can say voltage is 1 volt and current is 1 ampere, then we get 1 watt, right?
Yes,
One
sir.
volt into 1 ampere is equal to 1 watt. So for this we can write the statement. It is the power consumed by a device that carry 1 ampere of current when operated at a potential difference of 1 watt. Okay,
Yes, sir.
and what will be 1 kilowatt? 1 kilowatt power will be what? It is simply okay. We'll discuss this later. First of all, write this down.
Yes, sir. Done.
Okay, so the unit watt is very small. Okay,
Yes, sir.
we do not use this unit in our everyday life. Have you seen your meter, your electric meter? There you will see the energy consumed is kilowatt hour, right? Have you ever seen your electric meter? Hello.
Yes, sir. I've seen.
Okay. So watt is very small unit. Instead of watt, we use kilowatt. We can write it as 1 kilowatt. So what is 1 kilowatt? 1 kilowatt is nothing. This is power, right? 1 kilowatt is nothing but 1000 watts.
Yes, sir.
Okay. Since the electrical energy is product of power and time, power and time t, which is simply W is equal to P into T, right? So instead of joule, we use unit of energy as kilowatt hour. Okay, instead of joule, we use this unit kilowatt hour. Why? Because W is P into T. P is power. Power is measured in kilowatt, and time is measured in hour. So for electrical energy unit will be what? Kilowatt hour. Okay.
Yes, sir.
Okay, now what is 1 watt hour? If the energy consumed is 1 watt hour, that means what? It means 1 watt power is consumed for 1 hour, right?
Yes, sir.
So the commercial unit of electric energy is kilowatt hour, okay? Commonly known as unit. And 1 kilowatt hour is written as 1000 watt into hour, 1000 into 1 hour contains how many second?
Uh, 3600.
3600.
Yes, sir.
Okay, that means 3.6 into. Okay, let me first write it as 36 into how many zeros will be there? 3 and 2, which is 10 raised to 5, or we can write it as 3.6 into 10 raised to 6 joule. Okay,
Yes, sir.
or this is watt second. So this was our discussion on electrical power. Okay, so write this down here. Our electricity chapter ends, right? Okay, first of all, write this down and we'll get to some questions. Okay,
Yes, sir. Yes, sir. Done.
okay, give me just a second. Okay, so now you know what is electric power. So let's take one example. Okay, the question says an electric bulb is connected to a 220-volt generator. The current is 0.50 ampere. What is the power of the bulb? Can you do this?
Yes, sir.
Try this. Let me know the answer.
110 joules.
110 joule. Here we'll use
Yes,
one
sir.
watt. Okay. Power is voltage into current. Voltage is 220 volt and current is 0.50, which
Just one.
we can write it as 1 by 2, which is 110 watt or 110
Okay, sir.
joule per second. Okay, this is power, not
Yes, sir.
electrical energy.
Yes, sir.
Now if I modify this question, and you need okay, let me modify the question. Bulb is on for 1 hour. If the bulb is on for 1 hour, find out the electrical energy. Can you do this?
Yes, sir.
Tell me.
So what? I didn't understand what the second last word.
if the
Bulb is
bulb
on
if the
and
bulb
then
is
there's
on for 1 hour,
okay 1 hour. Sir, I do not know how to solve this. Okay.
what is power?
Power is VI volt into
Power is
current.
also energy per unit time, right?
Yes, sir.
So energy we can write it as P into T. So here it is electrical energy, which will be P into T. Power is 110 watt into time is 3600 second, right? So
Yes,
by calculating you will get your answer. Understand? I told you please remember all this formula. Now moving on to next question. And the question says an electric refrigerator rated 400 watt operates 8 hours per day. Okay, what is the cost of the energy to operate it for 30 days at 3 rupees per kilowatt hour? So this is the question. You need to find the cost of the energy to operate it for 30 days, 3 rupee per kilowatt hour. Can you do this? Here power
sir.
is
Can you
given in
call
what?
the formula for what is the kilo or the formula of kilowatt hour?
Brother, here power is given in watt. Okay, power is what here 400 watt. And remember what is 1 kilowatt? 1 kilowatt is nothing but 1000 watt. So if you take
Yes.
this 1000 to denominator, 1 by 1000 kilowatt is equal to 1 watt. So if we want to convert this into kilowatt, we just need to simply plug this value of 1 watt into this. Okay, what is 1 watt? It is nothing but 1 by 1000 kilowatt. Are you getting my
Yes.
point? So it will
Yes.
become, these zeros
Zero.
get cancelled out and we'll get 2 by 5 kilowatt. So now you know how to convert watt into kilowatt.
Yes, sir.
Simply remember 1 watt is equal to 1 by 1000 kilowatt. Okay? Now do this
Yes.
question. Okay. Are you getting the idea how to do this?
Yes, sir.
Okay. Do it.
So it will be 96 rupees.
Let me do it. So power is 2 by 5 kilowatt. Okay. So it is running 8 hour per day, right? Refrigerator. So one day, for one day, its total power will be what? 2 by 5
So one
kilowatt
will be
into 8,
yes, sir. So that is 16 by 5.
16 by 5 kilowatt. Okay, per day it is consuming, right?
Yes, sir.
Or we can simply say electrical energy per day is 16 by 5 kilowatt hour, right?
Yes,
Because
sir.
this expression is what? Power is nothing but energy per unit time. Here unit is hour, right?
Yes, sir.
So for electrical energy it becomes P into T. Power is 2 by 5 kilowatt and it runs for 1 hour, right?
Yes,
So
sir.
for 8 hour it is 16 by 5 kilowatt hour. That is the energy per day. So total energy for 30 days will be 1655 into 30, right?
Yes, sir.
5 6 are 30. 16 into 6,
Yes,
96
sir.
kilowatt hour. This is our energy, right? But the question says
Okay. So 3
We
times
need to
96.
find the cost of the energy.
So 3 times 96. Sorry, sir. I got that wrong.
Okay. And for 1 kilowatt, what was the value for 1 kilowatt hour? It's 3 rupees,
Um,
right?
yes, sir.
So for 96 kilowatt hour, its value will be what? That we need to find. It is simply 96 into 3,
288.
which will give
288
us
rupees.
288 rupees. So that will be our answer. Got it?
Yes, sir.
Okay, understood. Write this down and
Done,
let's
sir.
move
Done.
on. Done or what?
Done already, sir. Because I just
Now take one question more. An electric motor takes 5 ampere from a 220-volt line. Determine the power of the motor and the energy consumed in 2 hours. Can you do this?
yes, sir.
Try this handle.
So the power is 1100.
let, let me see. An electric motor takes 5 ampere from a 220-volt line. The voltage is 220. Determine the power of the motor and the energy consumed in time 2 hours. So first of all, power will be what? IV, which is 220 into 5, which will be what? 0, 0, 1, 11. Okay?
Yes, sir.
This is in watt. So electrical energy will be what? P into T, power into time. Power is 1100 watt into time is 2 hours. So 1100 into 2 hour, which is 2200 watt hour. But we need to convert this into kilowatt. Okay? So to convert watt into kilowatt, we simply divide it with 1000. So it becomes watt to kilowatt. Okay? Cancel these zeros. We get 2.2 kilowatt hour. That will be our answer. Done?
Yes, sir.
Any question?
No, sir.
Okay. Now let's move on to the question answer series, or we can say question answer section. In this, I'm not going to tell you the exact answer or anything. Okay? I'm just going to write the question and you need to tell me the answer. Okay?
Yes, sir.
And if it requires, I'm even going to tell you the options for the question. Okay?
Yes, sir.
The first question is a piece of wire of resistance R is cut into five equal parts. These five parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then find R by R dash. Can you do this?
Yes, sir.
Tell me the answer.
So this is R square by 5.
No. Suppose this is our resistor, okay? We cut this into
Yes.
five pieces. One, two, three, four, five. So its resistance will be what? R by 5, R by 5, R by 5, R by 5, R by 5. Because question itself says that we cut this into equal parts, right? And
Yes, sir.
then
Yes, sir.
and then we connect it into this series,
Parallel.
okay? Parallel combination. So this is R by 5, R by 5, R by 5, R by 5. So we know that for parallel combination, its resistance will be 1 by R by 5, which is
25.
simply
So
okay.
the answer
So
is 25.
yes, 25 is the answer. So its R equivalent will be, this is 25 by R. So R equivalent is R by 25. And it is given that R equivalent is R dash. And we need to find R upon R dash. R is R and R dash is what? R dash is what? R upon 25. So answer will be 25. Okay? Moving on to next question. Question number 2. So in this question, the question says, which of the following terms does not represent electric power? Options are, first is I square R, option B is IR square, option C is VI, and option D is V square upon R. What do you think? This is just an MCQ. What will be the answer for question number 2?
Represent electrical VI. Sir, VI.
Does not represent electric power. Does not.
Uh, sir, I. Yes, sir. IR square.
Okay, that is correct. It does not represent the electrical power. Okay. Question number 3.
Yes, sir.
An electric bulb. Write all this question down with me. Okay. I'm not giving. Okay, I'll give you the time after the completion of this series. Okay. An electric bulb is rated 220 volt and 100 watt. 100 watt. When it operated on 110 volt, the power consumed will be. Give me the answer quickly.
So, also will be 50 watt. 50 watt.
50 watt. That is the correct answer. Your data is given 220 volt. Volt is 220 volt and power is 100 watt. Right? So P is equal to VI. Here we can find the current, which is 10 by 22. You can say 5 by 11. Now it says when it operated on 110 volt, the power consumed will be. Power is VI. Current is 5 by 11 and it is 112. 110 is simply 10. So 50 watt will be the answer. Question number 4. Two conducting wires of the same material and of equal length and equal diameter are first connected in series and then parallelly. Sorry. Across same potential difference. The ratio of heat produced in series and parallel combination would be. Can you do this?
Yes, sir.
Try.
So 2 is to 1. In series, it's 2 is to 1.
Okay, two conducting wires of same material and equal length, okay, and equal diameters are first connected in series and then parallelly. Let's say its resistance is R. So in series, its equivalent resistance will be R plus R. That means 2R will be the resistance. So the heat produced will be what? I square RT for 1. For parallel combination, R equivalent will be nothing but R into R upon R plus R, which is R by 2. So the heat produced will be I square R by 2T. So its ratio will be W1 by W2. This is simply 2, or we can say ratio will be 2 is to 1.
Yes, sir.
Okay, next question. Sorry. A copper wire has diameter 0.5 mm and resistivity is 1.6 into 10 raised to minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? Okay, do this question.
Yes, sir. So 4:1 is the ratio. So that means
What ratio?
nothing, sir. So the answer will be um,
Just
2.5 ohms.
just tell me what is your approach? How we are going to do this? Tell me.
Also, we can find the L first, then we can continue.
What?
We can find the L first.
L. How we
So
are going to find it?
R equals to rho L by A.
Okay. R
So
is
first
equal
we find
to rho L by A. That means L is equal to RA upon rho.
right. Oh. So
Resist.
A we find
Okay.
is pi 16 pi.
16 pi how? Diameter is
One.
0.5. That means
Yes,
1
sir.
by 2. Okay. So its
Yes.
radius will be 1 by 4. So its area will be pi r square. That means pi by 16. Okay.
Oh, sorry, sir. Yes, sir.
So it is pi by 16. And resistance is what? 10 ohm. And resistivity was 1.6 into 10 raised to minus 8. Now see here. This is 10 pi upon. We can make it 16, right? By adding
Yes, sir.
one more power. So it is 16 into 10 raised to minus 9. This 16 comes to the denominator. Okay. So 10 pi upon 16 into 16 to 56 into 10 raised to minus 9. Okay. And let's take this pi as 3. Okay. We know that it is actually 3.14, but approximately it is 3. Now do this calculation and tell me the answer. 0.117. This 10 raised to minus 9 goes up and it will become positive, which is 10 raised to 9. So it is simply 1.171 into 10 raised to 8. But we have missed something. What we made? We made a major mistake. The diameter was in millimeter. Okay. So its radius
Oh,
will also be in millimeter. And to convert millimeter to meter, we just simply multiply with 10 raised to minus 3. Do you know how to convert millimeter into meter? Did you know?
meter to meter. Yes, sir. Times one. I think, yeah, 1,000.
1 meter is equal to 1000 millimeter.
1,000.
Okay? If we want to find the millimeter, then just take this 1000 to the denominator. So we get 1 millimeter is equal to 1 by 1000 meter. Okay? So
Yes, sir.
here we multiply with, now see, okay, we multiplied it with 10 raised to minus 3. Now it will get squared. Okay, so it will become 10 raised to minus 6. Are you getting my point? 10 raised to minus
Yes, sir.
3 whole square. Multiply this 3 to 2 and we'll get minus 6. This is the multiplication. So here we missed this 10 raised to minus 6. We'll get 1.171 into 10 raised to 2, which is simply 117 into 1. So that will be our length. And what else we need to find here? How much does the resistance change if the diameter is doubled? If the diameter is doubled, then what happen? What will happen? Can you find how much does the resistance change if the diameter gets double? So now we know what is the length of this wire. So simply we need to find the resistance. Resistance is nothing but rho A upon L, right? It is 1.6 into 10 raised to minus resistivity was what? Minus 8. Now new area will be what? So previous resistance was 0.5. Now it says it gets double. That means new diameter will be 1 millimeter. So the radius will be 1 by 2 millimeter. So its area will be pi r square, which is simply pi by 4 millimeter. So put this pi by 4 millimeter is 10 raised to minus 3 upon length is 117.1. Okay.
Yes, sir.
Now again do all this calculation, we take pi as 3. Okay, don't do this in your exam. Don't take pi as 3. Okay, here
Yes, sir.
we can fastly calculate all these things. That's why we are taking pi as 3. Else, in your exams, please take pi as 22 by 7 or 3.14. Okay,
Yes,
so
sir.
after all this calculation, we'll get the answer. I'm not going to calculate all these things. Okay, you will do this on your homework. Now, an interesting question. The question says, when a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistor. Do this. Try this question. What will be the answer?
4.8, sir. Value of the resistance is 4.8 ohms.
Let's see. V is equal. Here we are going to use Ohm's law. The resistance will be V by I. 12-volt, and it is 2.5 into 10 raised to minus 3 because it's in milliampere. So 12 by 2.5 into 10 raised to minus 3. What is 12? 12 by 25.
So 12 by 25 is so 12 by
Okay, 12 by 2.5 is 4.8. Okay, and this 10 raised to minus 3 will get to the numerator. So this is simply 4800. This will be the answer. How 4.8 resistance are you getting? Hmm? What
sir,
mistake
I
have you
cannot
made?
see the
Milliampere.
10 to the power 3. I wasn't able to see the 10 to the power
Okay.
3.
Don't make such type of silly mistakes. Okay, again,
Yes, sir.
question 9. A battery of 9 volt is connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4, 0.5, and 12 ohm respectively. How much current would flow through the 12 ohm resistor? Tell me.
So, my first question is, these 0.2 ohms, should I add them up along with 12 ohms, or I'm not
The
understanding
question
this
says
question. So,
in series.
okay, so,
This is the situation. These all are resistors, and there is one battery of 9 volt. What will be your approach?
sir, I will find the total resistance. So 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12 ohms will be the total resistance. And the total resistance is 13.4 ohms.
13.4.
Yes, sir.
Okay. Then,
So I equals to V by R.
okay.
So 90 by 134. I just moved the 10 up. Yes, sir. So then you can cancel by
Don't worry. Now you know that current remains same in series. Okay.
yes, sir.
So that's it. That will be our answer.
Oh, okay. Sir, I thought there will be like I thought I made a mistake.
No. If they told, if the question says that they are in parallel, then it will be a different thing. Okay. Do one thing. Instead of in series, write here parallelly. Do this by yourself in your homework. Okay. Then current will be different.
Yes, sir.
Now, okay, let's just find parallelly current through the 12 ohm resistors. So first of all, R equivalent will be what?
10 by 3 plus. Sir, is there 0.2 ohms? Sir, can you just. No, sir. Yes, sir. So it's 10 by 2
1
plus
by R
10 by 3,
equivalent is equal to 10 by 2, 10 by 3,
10 by
4,
4, and then
5
plus 10 by.
plus 1 by 12,
Yes, sir.
which is, okay,
Uh,
now we need to take LCM.
yes, sir. 20, 24, 60 will work, sir. Then there's something. So 60 we can use.
60.
Yes, sir.
So it is 30 into 10, which is 300, plus 20 into 3, right?
Yes,
200,
sir.
plus
Plus this is
15,
so
plus 60,
12, 130,
plus
60.
1, right?
Yes, sir. No, plus 5, sir.
How? Yes,
12, right?
yes, yes. So which will be 500 plus this 650?
120, not 60. Because 5 times 12 is 60.
Yes, 120. Okay, now get all these things. This is 650 plus 20 is 670 and 5, 675. Okay.
Yes, sir.
So our equivalent will be 60 by 675. Now the circuit will be like this. Okay,
Yes.
and so on. So first of all we have the voltage which is 9 volt. So current will be what? V is equal to IR, V by R, which is simply 9 by 60 into 675. This is total current. But we know that in parallel combination current gets divided. Okay.
Yes.
So for 12 ohm resistance, if we wish to find the current for 12 ohm resistance, we simply put the resistance itself, which is 12 ohm. Okay.
Yes, sir.
Voltage was 9, so I into 12. So current will be 9 by 12. So here you don't need to find out all these R equivalent. Okay. Simply write the
Yes,
value
sir.
of R and voltage. Then we can find the current. Okay.
Yes, sir.
So okay, I think there are still more questions are there, but we'll discuss in upcoming session. Okay.
Okay.
So